Hello students, today we'll be further seeing the other methods of distillation, and that is azeotropic and extractive distillation. Myself Prachi Joshi from Department of Pharmaceutical Technology. Now, first of all, what is azeotropic solution? You have already come across this word in the introductory part of distillation. Now, azeotropic solutions are those which boils at constant temperature without change in composition. Now what does that mean? Suppose you are taking any liquid which is having binary mixture, water and ethanol. You have taken water 4% and ethanol you have taken 96%, and you are heating it. Okay, so what happens is, in this two mixture, when it gets heated, there is no change in composition. Means what? That it will boil at, suppose it is boiling at 72 degrees Celsius, it will go on boiling at 72 degrees Celsius without change in composition. It, like, water will not become 3% and ethanol will not become 95 or 94%. So it is the characteristic most probably shown by non-ideal solution. Ideal solution will never show this type of characteristic. Okay, now azeotropic mixture are of two types: low boiling azeotropic mixture, or it is also known as positive azeotrope, or second is high boiling azeotropic mixture or negative azeotrope. Now what is the meaning of low boiling azeotropic mixture, or it is or positive one? Now it is the mixture basically boils at lower than that of any of its components. Okay, what does this mean? Water and ethanol mixture are there. Composition 4.03% of water is taken and 95.97% ethanol is taken. So what happens is, when the mixture boils, it boils at 78.2 degrees Celsius. It goes on boiling without changing in any composition. This will not become 3%. This will not become 95 or 94 or 93%. Likewise, which is, now this boiling point is lower than the boiling point of water and boiling point of ethanol. See, boiling point of water is 100 degrees Celsius and that of ethanol is 78.4 degrees Celsius. Ultimately, these two are higher and the mixture boiling point is much lower. Now what is the reason behind this? The major reason behind this is, now compared to water molecular attraction force and ethanol attraction force, water ethanol attraction force is less. Okay, water નું જે bonding છે એ બહુ જ high છે. ethanol નું bonding છે એ બહુ જ high છે. એ લોકોના attraction force જે છે they are higher. But water ને ethanol ને આપણે જ્યારે mix કરીએ છે ત્યારે એના bond જે attraction હોય છે તે કેવું હોય છે? less હોય છે. So શું થાય? એનું boiling point of the mixture becomes less. Okay, so it shows positive deviation from Raoult's law. Now, high boiling azeotropic mixture or negative azeotrope is one in which the boiling point is on the higher side. આપણે same example લઈએ, water nitric acid નું. Composition is 32% of water is taken and 68% nitric acid is taken. So what happens is, when this mixture is boiled, it is boiled at 125 degrees Celsius. 125.5 degrees Celsius. Now, boiling point of water is 100 degrees Celsius. Boiling point of nitric acid is 83%. But mixture નું કેટલું છે? વધારે છે આ બે કરતા. Individual કરતા બી વધારે છે. Why it is there? Opposite of this reason. આની અંદર શું હતું? અહીંયા શું થશે? Water and nitric acid molecular attraction would be much higher. Sorry, this is a printing mistake over here. Kindly correct it. Water nitric acid molecule. Okay, not ethanol but nitric acid molecule has lesser attraction force compared to water attraction and nitric acid molecular attraction. So it will give negative deviation from Raoult's law. Now this is just an introductory part. Now basic principle of this distillation is the principle of azeotrope or constant boiling point mixture, and extractive distillation suggests addition of a new substance to the mixture so as to increase the relative volatility of the one of the two key components and making separation relatively easy. Now, what does this mean? Basically, let's take an example so it will be much clearer. Now, there is azeotropic mixture of water and ethyl alcohol. So, as to increase the volatility, now this both are combined with each other. Now, to separate them both, what we are doing? We are adding the third component. Okay, and because of that, either water or ethanol will get separated first. See how. Now, benzene breaks the mixture of water and ethanol, okay, and forms new azeotrope between benzene and ethyl alcohol, okay. So, what happens is volatility of water is enhanced. So, water will quickly get separated, okay. On distillation, water is distilled at 65.85 degrees Celsius, leaving alcohol and benzene behind. So what will happen? Benzene and ethyl alcohol will form the bond, water will be kept aside and water will be getting separated first. Now, benzene gets distilled off at 78.3 degrees Celsius, leaving pure alcohol behind. Now, extractive distillation. The third substance added to the azeotropic mixture is relatively non-volatile liquid compared to the component to be separated. Now here in extractive one is what? Whatever you are adding the third component to the extractive, or you can say azeotropic mixture, the relative volatility of the liquid which you are adding, the third component which you are adding, is non-volatile, okay. The method is used for mixtures having a low value of relative volatility, which is nearly 1. What is relative? Basically, we are comparing from one to another. Okay, we have already studied what is relative volatility. We have already studied what is volatility. Okay, for example, separation of toluene from paraffin, hydrocarbons of approximately same molecular weights. Now, we are taking toluene and paraffin. Both molecular weight are comparatively same. The separation of toluene and isooctane is very much difficult. Correct? This is paraffin hydrocarbon, which is very difficult. However, in the presence of phenol, we are adding what? Phenol as a third component. Okay. The relative volatility of isooctane increases, and so the separation of toluene becomes easy. Okay. Application: to prepare absolute alcohol, and it is basically used in petroleum refineries and distilleries. Okay.